As we begin, let's remember that the types of passages we have dictate how we approach them. So if you have a data passage, you're going to quickly get to the information. If you have a research passage, you're going to take a few seconds to look at the variables, look at the different studies presented. A hybrid passage, you're going to treat more like research. That's where you get the steps of research that was conducted, more like a lab report. And then conflicts passage is going to be where you have scientist one or student one or method one, and you're going to have to spend time reading and examining the conflict and the different approaches. Now, as you map your path in science, you want to consider in what order you take the test. Generally, I think if you're a strong test taker or a strong reader, you want to do conflicts first, get it out of the way as there's not any shortcuts. If you're a slow test taker, conflicts is time consuming and you might want to save it till last, which means you might not answer it. If you're a really weak test taker or a weak reader, you're probably going to skip conflicts altogether. And that's going to lead you to how many questions you need to get for your target score. So you want to move up one level from your last test. So if you currently make a 23, you want to move to the 25 to 28 range. And so to do that, you need to answer 30 questions with confidence, and then letter of the day 10. So the range, remember, on ACT Science is not always forgiving. There's some tests you can miss 3 questions on and make a 36, 35. There's other tests you miss 3 questions, you drop to a 31, 32. So anyway, this lets you know kind of the range you should be in. So our first passage is a research passage. It goes with that experiments idea of the scientific methods. You're going to go in and look around and try to quickly understand the different variables. So as you quickly examine this one, you generally want to skim this first paragraph. It tells you what the passage is about. Researchers studied how diet and the ability to smell food can affect the lifespan of normal fruit flies and fruit flies unable to detect odors. So it's diet and smell. So study 1, there's 3 test tubes, 15% sugar use medium, 200 virgin females, 24 hours, and you're quickly skimming to see what's going on. Looks like the 3 test tubes are described. Study 2, 3 test tubes again, 5% sugar use medium, so I guess that's the diet, right? So 15 and 5%. Looks like everything else is the same, 200 virgin females, test tubes are described, and then you have these charts, percent alive in days, and then study 3 is going to be normal fruit flies and strain X fruit flies, and it looks like they're doing the ability to smell and not smell. And that's it, you move on. We did that in about 40 seconds, and that's about the time you want to take before you're to the questions. In which of the studies 1 and 2 did some of the fruit flies live for more than 75 days? So we want to put your fingers on studies 1 and 2, and you want to find 75 days, and you'll see that some of the fruit flies are still alive, and that is in study 2, which is 5% SY medium. During studies 1 and 2, why did the size of the fruit fly population in each tube decrease rather than increase? It sounds like it should be a joke. Okay, this is an if, suppose, why question. So anytime you have an if, suppose, why question, you're meant to think about it. So we're looking for why decreased rather than increased. Let's look at first choice H and J. They don't make logical sense. The death rate was 0 because it only contained males or females. That doesn't make logical sense. So we can eliminate H and J. And then we could go to the study and the reading. It says 200 virgin female flies were used. So the birth rate was 0 because it only contained virgin female flies. Study 1 differed from study 2 in which of the following ways? So we know from the last question that male fruit flies were not used. Only female fruit flies were used. And so we know we can eliminate choice A and B. So then we're going to say, we're going to look at the SY medium. So in study 1 and study 2, we have a 15% and a 5% SY medium. And in study, you always got to make sure you're looking at the right one. The SY medium in study 1 contained a higher percentage than study 2. So that would be correct. Suppose an additional trial in study 3 had been performed using a 12% SY medium, a diet with 12% sugar and 12% yeast, the average lifespan of strain X flies would most likely have been. Okay, so we're going to look at study 3, strain X, and we're going to do 12%. This is a supposed question, so you have to think about it. So draw a line between 10 and 15, and you'll see the lifespan is between 55 and 58 days. The researchers had predicted that decreasing a fruit fly's ability to detect odors would increase its lifespan. Are the results of study 3 consistent with this prediction? So we see in study 3 that strain X cannot smell, strain N can smell. So we're going to look at the percent mediums tested. We're going to see which one lives longer. Does X live longer than N? Yes, it does. So decreasing a fruit fly's ability to smell does increase its lifespan. And why? Because at each lifespan of strain X flies tested, it was longer than the average lifespan of strain N flies. So C is your answer. Okay, so this is a supposed question. So supposed questions ask you to think just a bit more. The researchers want to determine whether a defect in the ability to detect odors would change the lifespan of fruit flies fed a 15% SY medium when live yeast is added, or when additional odors from live yeast are added. Which of the following experiments should be performed? So we want to say, first, the 15% SY medium is study 1, so we have to repeat study 1, and then we also, the ability to detect odors is what we're testing. So N is normal, X lacks smell. So we want to repeat study 1 with strain X flies in order to test that hypothesis. So F. The results for which two tubes should be compared to determine how a reduced calorie diet affects lifespan in the absence of live yeast and additional odors from live yeast. So if we look at the studies, study 1 and study 2, study 1 has 15% yeast and study 2 has 5%. So we have to compare each study so we can eliminate B and C, because study 1 has tubes 1 to 3, study 2 has tubes 4 to 6, and we need one from each. So then we want to say which test tube has no additional odors, and that would be test tube 1. So we need test tube 1 in our study, so the answer has to be A. Okay, so this next passage is conflicts. Remember, this is like looking at an unusual sport and trying to figure out what's going on. There's not really a shortcut. You have to read and figure it out. Step 1 is to determine the conflict. In the fall, monarch butterflies in eastern North America migrate to Mexico, where they overwinter in high altitude forests. The butterflies store body lipids. They use it as a source of energy, so they eat. Consider the following 3 hypotheses pertaining to when the butterflies store lipids and when the energy for stored lipids is used with respect to migration and overwintering. So the conflict is that stored lipids, when do they use them with respect to overwintering? So when do butterflies eat and use their food as they prepare to travel to Mexico? That's the conflict. So step 2 is to determine the differences. In hypothesis 1, monarch butterflies require energy for stored lipids for migration and during overwintering. The butterflies store lipids before they begin their migration. During migration, as stored lipids are converted to energy, lipid mass continuously decreases. When the butterflies reach the overwintering sites, ending the migration, they must store lipids again before beginning the overwintering period. So they eat before they leave, they get thin as they travel, and they eat again when they get to Mexico for overwintering. Okay. Hypothesis 2, monarch butterflies require energy for stored lipids for migration. The butterflies store lipids before they begin, so that's similar to hypothesis 1. During migration, the mass continuously decreases, also similar to hypothesis 1. Because the energy for stored lipids is not required during overwintering, they do not store lipids while at the overwintering site. So they eat before they leave, they get thin as they travel, and they do not eat when they get to Mexico. Right? They get there and they go, oh man, I'm tired, and they just relax. And then hypothesis 3, monarch butterflies require energy for stored lipids during overwintering but not migration. The butterflies do not store lipids before they begin. Instead, they're stored during migration and their mass increases.
Okay, so they don't eat before they leave, like 1 and 2. They eat as they go. They're stopping and getting some fast food on the way. And they get fatter as they go. The butterflies arrive at the overwintering site with enough lipids to provide themselves with energy, so they do not store lipids while at the overwintering site. They don't eat before they go. They eat as they go and get fatter, and they don't eat in Mexico. Which hypothesis, if any, asserts that monarch butterflies stored lipids during two distinct periods? So we look back and we say in hypothesis 1, they eat before they leave and they eat when they get to Mexico. So it has to be hypothesis 1. Which hypothesis, if any, asserts that monarch butterflies require energy from stored lipids neither for migration nor during the overwintering period? So which one says they don't need any food at all? And none of them do. These eat before they leave, these eat before they leave, these eat as they go. So they all say they need food in some way, so none of the hypotheses say that. Based on hypothesis 3, which of the following figures best depicts the change in lipid mass of a monarch butterfly from the beginning of migration to the end? Okay, so hypothesis 3, they eat as they go and they get fatter. They don't eat before they go. So which one says they get fatter as they go? That's choice J. As time increases, their mass increases. Number 11, assume that changes in body mass of a butterfly are caused only by changes in the mass of stored lipids. The statement, the percent of monarch's butterfly's body mass that is made up of lipids is greater at the beginning than at the end of migration, is supported by which hypothesis? So which butterflies lose mass as they go? So if we go back to our ideas, the ones that are annotations, the ones that lose mass are hypothesis 1 and hypothesis 2. So our answer has to be 1 and 2 only, so C. To store lipids, monarch butterflies convert sugar from nectar they have consumed into lipids, a supporter of which hypotheses, if any, would be likely to claim that to ensure the butterfly can store lipids for overwintering, nectar must be present at the butterfly's overwintering site. So which ones eat when they get there? Right? The one that eats when they get there is hypothesis 1. All the others do not eat. So has to be hypothesis 1. Which of the following statements about lipids in monarch butterflies is consistent with all three hypotheses? The butterfly's mass does not change during the overwintering period. Well, that's not true because butterfly 3 gets fatter. The butterfly's lipid mass changes during migration. That's true. Butterflies 1 and 2 lose mass and butterfly 3 gains mass, so B. When monarch butterflies use their stored lipids, the lipids must be broken down to produce energy-rich molecules that can be readily used by cells. Which of the following molecules is produced as a direct result of the breakdown of lipids? This is a science knowledge question that you either know or you don't know. And so the answer is ATP. You're going to have somewhere between 2 and 4 questions either about science knowledge or science process on the test. All right, our next passage is a data passage. You're going to quickly go in, assess the details. It's like looking at Where's Waldo, right? Here's a space scene. Looks like they can't breathe in the atmosphere. It's crowded. They're in domes. There's spaceships. There's asteroids. Great. Moving on to the passage. So passage 3, greenhouse gases such as methane warm Earth's climate. So we're going to use something with methane. We're not going to read all this because it's a data passage. So we're going to see we have figure 1, which has solar radiation intensity over thousands of years, concentration of CH4 in the atmosphere, and solar radiation CH4 concentration in these lines as well. And figure 2, solar radiation intensity again, thousands of years, concentration in solar radiation and CH4 concentration. All right, and then we go to the questions. According to figure 2, the solar radiation intensity 8,000 years ago. So put your finger on figure 2, find solar radiation. So that's going to be the dotted line, 8,000 years. Put your finger on 8,000 years. I want you to draw a line straight up till you hit the dotted line of solar radiation and then over. And that's at about 500. So your answer is C. Number 16 is an if suppose why question. According to the figure 2, if the trend in CH4 had to continue to match the trend in solar radiation intensity, CH4 concentration at present would be. All right, so we're using figure 2, and we're going to say CH4, so the straight line, is going to match the solar radiation line. So at present, it would be less than 550. Number 17, we have another if suppose why question. Suppose that when CH4 concentration increases, a corresponding immediate increase in average global temperature occurs. And then whenever CH4 decreases, a corresponding decrease occurs. So CH4 is going to match temperature. Okay, which of the following graphs best represents the plot of the average global temperature in the past 11,000 years according to figure 2. Okay, so CH4, so our chart has to match this, and which one best matches that is going to be choice B. Number 18, based on figure 1, so we're going to pull up figure 1, the average solar radiation, so solar radiation is the dotted line, intensity over the past 250,000 years, we're using the whole chart, was closest to what? So draw a line right through the middle, and that looks like they're about the same on each side. So 480 is probably your answer. You can use the other two to process of eliminate if you want to. 400 is way too low, 440 is way too low, 520 is way too high. So your answer has to be H. One solar radiation cycle is the time between a maximum in solar radiation intensity and the next maximum. According to figure 1, the average length of a cycle over the past 250,000 years. So find solar radiation is the dotted line, put your finger on the first maximum, and then it's between each one, right? So that's the difference between each one. You don't really have to calculate the average because they look about the same, right? So just do the first one. So from that one to that one is 20, and your answer choices, choice B is between 15,000 and 35,000 years. So B has to be your correct answer. Which of the following statements best describes the effect of CH4 on Earth's climate? So one or two will come from the reading or science knowledge. And so this one in the reading, it says greenhouse gas warms the Earth climate, methane. So does it give off visible light? No. Give off ultraviolet light? No. Cool Earth's climate? No. Warm Earth's climate? Yes. J has to be our answer. All right, our next passage is also a data passage. It's like Where's Waldo again. You're quickly examining the information and then move. So passage 4 might look a little bit like a research passage, experiment 1, experiment 2. And if you treat it like that and read it a little more carefully, it's not a problem, but you can get through it quickly either way. This is a short one. The two experiments, students pull 3 blocks in a straight line across a flat horizontal surface. And the first one looks like they're looking at pulling force and block mass. And the second one, they're looking at speed and time, and then you move on to the questions. If a block was pulled towards the east, the frictional force exerted on the block by the surface was directed towards which directions? This is science knowledge. You have to understand your cardinal directions, north, south, east, west, and know that friction works against an object. So the opposite of east is west. Based on figure 2, so we're using figure 2, what is the order of the 3 blocks from the block that require the shortest time to reach the 15 millimeters per second or meters per second, doesn't matter what it is, m per second, to the block that required the longest time? So go to 15, draw your line straight across, and which one got to that line first, second, and third? 2, 2.5, and then 3, so F. Based on figure 2, so we're using figure 2 again, what's the approximate value of acceleration of the 3 kilogram blocks? We're using the 3 kilogram block. We have to know acceleration equals speed divided by time. So it's a little bit of knowledge included in this one. So speed divided by time. So I'm going to use 15 and 3. You could use 10 and 2 or 5 and 1. I don't know why I chose 15 and 3, but I did. 15 divided by 3 is 5. So your answer is B. Based on figure 1, the results of experiment 1. So now we're in figure 1. We've been in figure 2, so make sure you're looking at the correct place. So put your finger on it. The results of experiment 1 are best modeled by which the following equations. So if you're looking in the right place, speed is not a part of figure 1. It's pulling force and block mass. So we can get rid of F and G. But pulling force is. So if we look at these data points, if we choose choice H, 0.2 times 1 would be 0.2. But 5 times 1 would be 5. And 5 times 2 would be, 2 times 5 would be 10. So J has to be your correct answer, just following the equation that is presented to you. At each of the times plotted in figure 2, so we're using figure 2 again, except 0 seconds, as block mass increased, so what happens to block speed? So the block mass, is what we're looking at, goes from 2.5 to 3, and as we do that, the speed gets slower, right? So it's decreased only. The speed gets slower as the blocks get heavier. Based on figure 1, so we're using figure 1 again, and we're looking for an applied force of 30 newtons. But 30 is not there. It only goes up to 25, right? It stops at 25. So you got to figure out, well, what do? What would be the most likely have been required to maintain the constant speed block having a mass of? Okay, so there's two ways you can do this. You can calculate it or you can draw it. If you calculate it, you can set up a proportion using a known data point. So force over mass. So force is 5 and mass is 1. Force is 5, mass is 1. We want to know what 30 would be, so equals 30 over x, cross multiply, solve for x, you get x equals 6. The other method would be to draw it. If you draw it, 30 is going to be up here. It's a direct variation. It continues up. You can draw the line over until you get to the line hits. You can use your answer sheet as a straight edge, and you're going to still get 5, 5.5, and a little more if you draw it pretty good. And that's going to be 6 as well. So your answer has to be H. Okay, so our next passage is experiments. This one's more like lifeguarding. You want to check out the variables, know what's going on. It takes a little more time than data, but to the questions in less than a minute. So a typical acid-based indicator is of a compound that will be one color over a certain pH and a different color over a higher pH. In the small range between those is the transition range. Students studied 5 indicators using a well plate. Okay, experiment 1 looks like they're using the indicators in a pH of 1 to 7. You can kind of skim that to see. Experiment 2 is repeated with a pH of 8 and higher, so the same indicators that are described in the first paragraph, and then 8 to 14 pH. Experiment 3, students were given 4 solutions of an unknown pH, so the same indicators. It's missing one, looks like that one, and they tested them of their unknown pH. And that's it, you move on. We did that in about 40 seconds. One way experiment 2 differed from experiment 3 was in experiment 2. So we're looking at experiments 2 and 3, and I first see Mentonol yellow in choice C and D. So I see that's used in both experiment 2 and 3. So that's a pretty easy one to eliminate because it's in both of them. So now we have to say choice A, the solutions to which the indicators were added were of a known pH, or the solutions were added were of an unknown. You need to read this as it's stated in the question. In experiment 2, and they do know the pH, the solutions to which the indicators were added were of a known pH. So if it had said in experiment 3, then the answer would have been B. So you just got to pay attention to the reading. Based on the description of the well plate and how it was used, the empty well plate would most likely have been which of the following colors. So the description is in the second paragraph. It says a well plate, a plate containing a matrix of round depressions. So it's something they're dropping liquid into. And how it was used is in the next paragraph, described in experiment 1, where the students are adding a drop of liquid to see what color it changes. So this is really a science, knowledge, art question. If you're adding liquid to a plate and you want to see what color it changes, you want it to be white. Any of the other colors, you want to be certain what color it was. So blue, if you had a blue plate and it changed to red, it would look purple. Based on the results of experiment 1 and 2, which of the following is a possible transition range for curcumin? So find experiment 1 and 2 and curcumin. We want to see where it transitions. and it does between 7 and 8, so our answer has to be between 7 and 8, which is C. A chemist has two solutions, one of a pH 1 and one of a pH 6. Based on the results of experiments 1 and 2, could indigo carmine be used to distinguish between these two solutions? Well, we really only need experiment 1 because it has pH 1 and 6 on it. Experiment 2 has 8 and above. So find indigo carmine, experiment 1 and 6. We see at 1 it's blue, and at 6 it's blue. So it could not be used to distinguish because it's blue at both 1 and 6. The indicator propyl red, and notice that's in italics, and ACT will put things in italics in the question if it's new information, has a transition range of pH 4.6 to 6.8 if, suppose Y question, you're going to have to think about it, if propyl red had been included in experiments 1 and 2, it would have produced results most similar to those produced by which of the 5 indicators, and really just 4 because we only have 4 choices. So experiment 1, we're going to look at pH of 4 to 6. We want to find one that has a transition range in that area, and we see it there. Rocerin blue goes from red to purple, so it would be most similar to Rocerin blue. A student claimed that solution 3 has a pH of 7.3. So let's look at solution 3, and then a pH of 7.3, so that's going to be in experiment 1. Are the results of experiment 1 to 3 consistent with this claim? So choice F, menthol yellow. So let's look at menthol yellow. It's yellow in solution 3, and it's also yellow in pH 7, so that would mean that it would be consistent, so that would be a yes. So we're going to eliminate F. Now G, Rocerin blue. Okay, Rocerin blue is red in 3, but it's blue at 7.3, so that means it's not consistent. So that would mean that no, because in solution 3, blue was red. It's kind of an odd way to state that one, can be confusing. Based on the results of experiments 1 to 3, so we're using all 3, which of the solutions 1 to 4 has the lowest pH? So we're going to look in experiment 3, and it's the lowest pH, so I'm looking at menthol yellow because it has 3 yellows and 1 orange, and so that means it can easily be used to distinguish, probably. So we see 1, 2, and 3 are yellow, and we look over at our indicators in experiments 1 and 2, it's yellow all the way from 3 to 14. But then orange in solution 4 is at a pH of 2. So we know now that orange is the lowest pH, so solution 4 has the lowest pH. It's a little bit of a tricky question on a timed test. Might take you a minute to figure that one out. Okay, our last passage is like a lab report. It's a research/data passage. It gives the steps included in the research. So you're going to approach it kind of like you would a research passage, just quickly skimming the information, looking at the data points, and then going to the questions. So in this passage, we see drilling mud is a suspension of clay particles. When a well is drilled, DM is ejected to lubricate the drill, and is brought back to the surface and sprayed on adjacent lands. So you know what drilling mud is. A cover of drilling mud can affect albedo, it's in italics, know what it is, the portion of total incoming solar radiation that is reflected, which can in turn reflect soil temperature. Okay, and there looks like they're looking from July 1 to 9 in a particular year at albedo and temperature, and 3 plots, and tells how much was sprayed. And then it says for each plot, albedo was calculated on a cloudless day. So there's albedo, and there's June to August. And then for each plot, the sensor recorded the soil temperature every 5 seconds. So daily soil temperature and the dates. All right, so you get a basic idea, and then you move to the questions. Albedo is measured at noon because that time of day is when solar radiation is. All right, so albedo, let's first see what that is. It's the proportion of total incoming solar radiation that is reflected from the surface. That's in paragraph 2. So it's 100% reflected. Now nothing's really 100% reflected any time of day. 100% absorbed, no. Least intense or most intense? Well, at noon, we know the sun is most intense, not least intense. So it has to be J. So that's a science reasoning question. Why was the study designed? So an if, suppose, why question. So that the three plot to the same types of vegetation present and the same density of vegetation cover. These conditions ensured that any variations in albedo and soil temperature would most likely be attributed only to variations among the plots in the, so this is a science reasoning question as well about the process. And it says in the second paragraph, the effect of the cover of DM was studied. So that's what they're studying, is the effect of DM. So they don't want it to be attributed to anything else. So it has to be A. On one day of the study period, a measurable rainfall occurred in the study area. The albedo calculated for the cloudless day. So let's find the chart that uses albedo, and that's figure 1. Well, just after the rainy day was lower than the albedo calculated for the cloudless day just before. So before is bigger, after is smaller. On which day did a measurable rainfall occur? So we can process of eliminate the dates. So we'll start with July 10th. Is before bigger? No. After smaller? No. So that's out. July 12th. Is before bigger and after smaller? No. So that one's out. But when we get to July 26th, yes, that works. Before is bigger and after is smaller. You probably get to see that in the chart, but you can process of eliminate just to be sure if you need. For each plot, the number of temperature readings, we need the temperature reading chart, recorded by the soil temperature sensor every minute was closest to, and the reading, it tells us that it was recorded every 5 seconds. So there's 60 seconds in a minute. 60 divided by 5 is 12. That one's a little bit tricky because you have to find it in the reading. It's not hard, it's just tricky on a time test. According to figure 1 and the description of the study was July 20th, a cloudless day. So figure 1 and the description, July 20th. So July 20th, and the description says albedo was collected for each cloudless day. There are no data points for July 20th. So no, albedo was, because albedo data was not collected on that day. If it had been cloudless, they would have collected data. Okay, I think this is one of the hardest questions in the test for a timed test. If you had unlimited time, it's pretty easy. Well, not easy, but it's easier. But as is, it's a hard question. According to the results of the study, did the presence of a cover of DM increase or decrease the albedo, and the presence of a cover of DM increase or decrease soil temperature? So let's start with albedo. Okay, so find the albedo chart. It's figure 1. Now, the tricky part is when you look at it, you might just look at one of these graphs and say, oh, well, it looks like it's going up, so it increases, right? Because there's a steady rise. But that's not really how you do this one. You have to actually figure out which plot has drilling mud on it, because this measures albedo, not drilling mud. So you have to find from the reading, and it says an amount of drilling mud equivalent to 40 cubic meters per hectare was sprayed evenly on plot 2. An equivalent was sprayed on plot 3. No drilling mud was sprayed on plot 1. So plot 1 is the control. So plot 1 does not have any. So now we go back up and we see that plots 2 and 3 are lower than plot 1. So the presence of drilling mud caused a decrease in albedo. Now, so we know the answer C or D. Now we look at soil temperature. And soil temperature, we can compare plot 1 and 2 and 3 to plot 1 as well. So the temperature is higher for plots 2 and 3, so there is an increase. So your answer is D. And that's just a lot of information to process on a timed test towards the end of the test. And it's a tricky question because of that reason. And then ACT gives you one more decently tricky question for the end of the test. Based on figure 1 on August 3rd, so figure 1, August 3rd, what percent of incoming solar radiation was not reflected from plot 2? So plot 2, we go up to, on August 3rd, We draw a line over and we see 0.20, and you're tempted to answer F. But you have to remember what albedo is. Albedo is the total incoming solar radiation that is reflected. We want to know what is not reflected. So 100 minus 20 is 80. So 80% is not reflected. And that's a tricky question for the last one because the distractor is so tempting. And I can tell you a lot of students miss this question. Okay, so that finishes the test. Let me know if you have any questions.